Tesla's remarkable expansion in Austin hints at more than just growth, with employment at Gigafactory Texas nearly doubling to close to 23,000 workers by the end of the year 2023. Many observers believe Tesla is quietly preparing for a massive leap forward. While Elon Musk has not officially confirmed it, more and more industry experts are turning their attention to the much-awaited Model 2 as Tesla's next major move. Believed to start at just $9,875 United States dollars, the Model 2 is rumored to use Axial Flux Motor technology, a compact and highly efficient system that could bring better performance while keeping production costs lower. And powered by the production strength of Texas, this could mark the start of Tesla's next major chapter, making electric vehicles truly within reach for people everywhere. Welcome to Amp Drive, your number one space for everything about Tesla, innovation, and future technology. If you are excited about how Tesla is changing the game, make sure to hit that subscribe button now. We are just getting started and would love for you to be part of our growing Amp Drive community. 1. Have you ever realized that the true power of an electric vehicle often lies in its motor? And that this new kind of motor might be the breakthrough Tesla needs for its Model 2. Axial Flux Motors represent a modern generation of electric motor design, and they are expected to play a key role in Tesla's upcoming affordable vehicle. Unlike older radial flux motors, where magnetic force moves outward from the center like a tube, axial flux motors guide magnetic energy through a flat, disc-shaped setup. This main difference creates a motor that is flatter and more compact, often nicknamed a pancake motor. In structure, an axial flux motor normally includes two flat stators with copper windings, placed on both sides of a central rotor with strong permanent magnets. This design gives a larger active area for creating torque while keeping the motor thin. While many radial motors are large and bulky, sometimes stretching several hundred millimeters in length, axial flux motors can be just 50 to 100 millimeters thick, even while delivering the same or more power. This small size brings a huge impact. By using axial flux motors, Tesla is not just saving room. It is getting the Model 2 ready for stronger performance, better energy use, and more flexibility in vehicle layout. For instance, axial flux motors can offer between 30 to 50% more power for their size and weight than older motor types. A motor that weighs only 20 kilograms might generate as much as 250 kilowatts of power, making it perfect for a small, affordable car like the Model 2 without giving up speed or quick acceleration. Because axial flux motors are smaller, Tesla's design team can reimagine the layout of the vehicle. Rather than being stuck with a big round motor in the middle, this flatter pancake-shaped motor can be placed closer to the wheels or fit into tight spots, giving the car better balance and easier control. The flat shape also spreads out heat better, lowering the chances of overheating during fast drives or long trips. Some studies show that axial flux motors can cool 30% better than older motor designs, which improves dependability and long-term performance. From a factory viewpoint, axial flux motors bring real value too. They use fewer pieces and have a more basic design that gets rid of long rods and extra support pieces. This makes them quicker and cheaper to build. Once mass production kicks in, Tesla could reduce costs by 10 to 15% per motor, a big deal for reaching that $9,875 entry price. So what do you think? Can a smaller and thinner motor like this really help Tesla make the Model 2 more affordable and more practical for everyday drivers? Comment Axial Flux below if you believe this technology is the key to helping the Model 2 win the electric vehicle market. 2. How does axial flux motor tech help the Model 2 go further, speed up faster, and lose less power with every drive? The adoption of axial flux motors is expected to give clear improvements in driving and energy savings, changes drivers will feel right away. One of the biggest advantages is longer range. Thanks to higher efficiency, axial flux motors can convert between 96 to 98% of battery energy into real motion, compared to around 92 to 94% in older motors. While those numbers may seem close, over long drives, the difference really matters. For example, if a car is expected to go 300 miles per charge, this better efficiency could stretch the range by another 15 to 20 miles. Another big benefit is fast torque. Because axial flux motors have a shorter magnetic path and flat build, they deliver torque more directly and with quicker reaction. This means faster pickup, especially at lower speeds where electric vehicles already perform well. For the Model 2, this means sharper 0 to 60 times and smoother handling in everyday driving, whether you are weaving through traffic or joining the freeway. Lower energy loss is also key. Because of their flat design, axial flux motors create less heat when running. Since less power is wasted as heat, more of the energy in the battery is used to move the car. This also lowers the load on the cooling system, which helps improve how long parts last and cuts down on upkeep. Regenerative braking is another area where these motors shine. The precise magnetic control in axial flux motors means smoother and more effective energy capture when the car slows down. That means a higher percentage of motion energy is saved and sent back to the battery, helping to stretch your range even more. Experts estimate that regen braking systems with axial flux motors can improve recovery by 10 to 15% over older designs. 3. Have you thought about how Tesla's Model 2 could look and handle differently because of its slim, compact motor? The use of axial flux motors is expected to affect not only performance, but also the way the car feels and drives. Their pancake-like shape, just 50 to 100 mm thick, lets Tesla build the Model 2 with a lower stance, helping it sit closer to the road. A lower ride height improves how the car cuts through air, boosting energy efficiency. Even dropping the height by 20 to 30 mm can cut air drag enough to stretch the driving range by 5 to 7% without needing a bigger battery. This also gives the Model 2 a more modern and sleek shape while keeping energy use low. With the flat motor, Tesla engineers also have more freedom in where they place wheels and suspension parts. Since there is no big motor in the middle, the wheels can be moved closer to the edges, improving stability. It also creates more room inside for people and storage. In a smaller vehicle like the Model 2, every inch counts, and this setup can make the inside feel more open while improving turning and lane shifts. The outside body gets benefits too. The motor's small shape means there is no need for big motor housings that break up the smooth car shape. Tesla can design the outside to be cleaner and more efficient, both in looks and in air resistance. Also, the lighter weight helps. Axial flux motors weigh 10 to 20% less than older types. By putting these lighter motors near the car's center, Tesla can balance the Model 2 better from front to back. This gives better control during turns, stops, and quick moves, especially useful for tight city driving. If you think a slimmer motor could really make the Model 2 look better and handle more smoothly in traffic, comment, Model 2 wins, and let us know what excites you most. 4. Have you ever imagined how Tesla's Model 2 might feel roomier and more user-friendly, all thanks to this compact motor? The arrival of axial flux motor tech is going to affect not just the way the Model 2 drives but also how it feels inside the cabin. One big change is the added space. Axial flux motors take up less space than radial ones. While an average radial motor might take up 70 to 90 liters of space under the floor, axial flux motors only use 50 to 65 liters. This 30% volume cut gives more space for seating and storage. In a small car like the Model 2, that makes a big difference. It can mean more legroom in the back, a larger trunk, and smarter use of every inch inside the car. Another clear win is the flat interior floor. Many electric vehicles still have small floor bumps left over from motor placement. But with Axial Flux's slim design, Tesla can give the Model 2 a truly flat floor from front to back, adding 30 to 50 millimeters of extra foot space in the back row. It also makes room for underfloor storage and lets the seating layout be more flexible. That flexibility allows for creative options. With fewer parts under the floor and fewer motor housings in the way, Tesla designers can explore things like sliding back seats, fold-flat front seats, or adjustable cargo sections. This can increase storage space by 10 to 15% and help owners make the most of it depending on their needs. Another plus is a lower step-in height. Thanks to the flatter underbody, Tesla can lower the car's stance by 20 to 30 millimeters without losing needed clearance for city roads. That makes getting in and out easier. Studies show that even a 20mm drop can cut the physical effort by 5 to 8%, a real help for kids, seniors, or anyone carrying heavy bags. 5. How is Tesla using this motor to make the Model 2 not only more powerful but also more dependable and ready for what's next? Axial Flux Motor tech is not just about better driving. It is also about making the Model 2 cheaper to build, easier to maintain, and cleaner for the environment. One major plus is the lower production cost. Because the motor design is simpler and flatter, with fewer parts, it is easier and quicker to build. Experts say costs can be cut by 10 to 15% per motor. This is key to hitting the $9,875 target price while still keeping profits healthy. They are also more reliable. With fewer parts that can wear out and cooler operation thanks to better heat flow, these motors last longer and need less repair. That matters a lot for high-volume cars like the Model 2, where keeping maintenance low is a must. They also scale better. Since they are easier to make and need fewer special tools, Tesla can grow production faster, especially in places like Gigafactory, Texas, where output is expected to rise quickly. This matches Tesla's mission to deliver millions of affordable electric vehicles every year without making the factories too complex. Looking to the future, axial flux motors give Tesla a flexible platform for other vehicles beyond the Model 2. Their size and performance make them a good fit for all kinds of cars, from small sedans to delivery vans. By making this motor the standard, Tesla stays ready as electric vehicle tech keeps changing. And finally, they are more planet-friendly. Since they use battery power more efficiently and waste less as heat, they leave a smaller carbon footprint. Plus, needing fewer raw materials helps ease the load on nature during factory work. Tesla's quiet push into new motors, factory growth, and careful planning seems to be aiming at something big. The arrival of the Model 2, powered by axial flux motors, could make the year 2026 the real beginning of electric vehicles going mainstream around the world. This motor tech may be the key not just to one car, but to a brand new future of cleaner, smarter driving for everyone, and here at AMP Drive, we will keep you updated every step of the way.